It's like a glitch.
This is the Gambit screen. Okay, I'm choosing solver, which is Fluent. Okay, now you can save the file before you begin, or else you can also save in the end. Now the task is to model the problem, which we have already discussed in the previous video. So that is a backward step problem. Okay, and I start the model with the creation of vertex. So the vertex can be created using this operations facility. You can create geometry. Starts with vertex, edge, face, as I told you. So creating vertex. This is the coordinate system, default coordinate system, which is there already as chosen, and it is a Cartesian coordinate system. What I will do is, there is no three-dimensional scenario. We are modeling only 2D problem. So let us begin with the z-axis is negligible. Okay, 0. You never do anything with z-axis. So I choose a point which is 0, 0, x0, y0, and I created a vertex. You can see that, right? And with y1, I create another vertex, right? y1, and let's have 3 units x and create another y, and create at y0 at 3, and also at y minus 1 at x3, right? That is what we are having a step, right? That. And now let's take x to 20 and create another vertex, and y0 another vertex, and y1 the last vertex. So close it, come to edge, creating an edge. So I pick this 2 vertices and create edge, and so on. Okay, I continue the same process, pick the vertices and create edge, go like this step by step, and you can have, this is the model actually, and I also create another edge there and here, so that if you can look at the model, you, when you create like this, you can play with the mesh elements, sizes and all. That's why it's always better to create like that. Create different blocks kind of thing, and then play with the meshing part. So then once you end up with creating an edge, and then you come to face, creation of face, and choose the edges and try to create face. You end up with 3 faces, right? This is the last face. There are 3 faces. You can highlight here shaded one, and you can see that. Now wireframe shaded. Okay. Now we have 3 faces, right? Don't worry, 3 faces, we can group them together, and let's choose all the 3 faces. Okay, and name it as one single problem, that is back underscore step. Okay, I name it as back step. Okay, that's a group. You can see that may not be bright enough to find you there. Now let's choose this group, which is this is let's choose the group which is back step, and identify it as a fluid. Okay, there are 2 types like solid or fluid. And so I identify it as a fluid. Okay, you can show the color. Now it's a fluid, and you can also name it as a fluid, right? And now come here to the boundary conditions. This is this edge is uh, velocity inlet, as in our problem. Okay, at a particular velocity, fluid is going to enter here and flow like that. That's the velocity inlet, and this is a pressure outlet, boundary condition, pressure outlet, right? And these are walls. Okay, these are walls, wall type boundary condition. And don't worry, here we have not given this edge and this edge boundary condition. You can name it as interior. Okay, you need not show labels there. You can, that's how the interiors will not appear to you, right? Now come to meshing, face mesh. Now what we'll do is choose this face, right? I go little 0.05 is the size. I go 0.05 with this, and 0.04 with this, and 0.03 with this. I want to see what's happening here more carefully. Now I go with 0.04 there, okay, little finer, and here in this one 0.03, okay, much finer mesh. This is how the problem looks like once you generate the mesh. Now what we'll finally do, we have modeled, we have decided the zones, like what is this, fluid or what, and this defined the boundary conditions, then meshed, and we are now going to ready to export mesh. Just give a name like back underscore step, all small, okay, export 2D, accept. Now you can find there, down there, mesh was successfully written to back underscore step dot mesh. So this is how we have to model the problem in Gambit.